Inverse sine, of course, is the inverse of the sine function. Inverse sine is defined as follows. We can take the inverse sine of any value that is between and including -1 and 1. All right, so we can't take the inverse sine of anything that's greater than 1, and we can't take the inverse sine of anything that's less than -1. The actual answers that we get out are going to be between -pi/2 and pi/2. Okay, and so I'm not sure if you can realize, but we're going to actually, it's kind of like we're working backwards. So y equals inverse sine of x. That actually means that x is equal to the sine of y. So we will have a value in here for x, like the inverse sine, say, of +1, or the inverse sine of square root of 2/2. So we're actually going to have, it's kind of like we have the answers that you're used to finding in here, and what we want to do is we want to figure out, well, which angle measure would I have to evaluate sine at to give me that answer. And we have to keep in mind where all of our answers need to come from. All of the answers for inverse sine need to be between -pi/2 and pi/2. So if we were to look at that, think about your salty sea chart. This tells us where all of the trig functions are positive and all the trig functions are negative. All the trig functions are positive in the first quadrant. Sine and cosecant are positive in the second quadrant. Everything else is negative. Tangent and cotangent are positive in the third quadrant. Everything else is negative. Cosine and secant are positive in the fourth quadrant. Everything else is negative. Now notice where inverse sine is defined. It's defined between -pi/2 and pi/2. Okay, so all of your answers, all of your angle measures that you're going to want to get when you work out an inverse sine problem need to be between -pi/2 and pi/2. Now don't get that confused with, down here on the negative y-axis we have 3pi/2. That's where 3pi/2 is located. Well, that's also where -pi/2 is located. So it really wouldn't make sense if I was to say I want to get all of my answers between 3pi/2 and pi/2, because right here is 0 or 2 pi, and we do start over when we get back here to 0, but we don't, right? It's kind of like if I was at 2 pi and I added pi/2 again, I'd be at 5 pi/2. So there has to be some way to classify which answers that we want. And mathematicians got together and they decided, well, we have to pick something, so let's pick two quadrants that are consecutive where sine would be positive and sine would be negative. Okay, so do you see why when this great mathematical conference came together in this meeting of the minds decided upon where we're going to define inverse sine? Can you see why it's not between 0 and pi? Because if it was, if we defined the inverse sine between 0 and pi, then all we could get would be positive answers, right? Because sine is positive in both those quadrants. So using the fourth quadrant and the first quadrant, we have all positive and negative answers covered. Now, another way to look at this is to think about the sine curve. All right, the sine curve looks like this, and if we look between -pi/2 and pi/2, then that will give us, if you trace from the graph over to the y-axis, that will give us all the answers for sine that we can get out. All the negative answers and all the positive answers. And so if we just take that piece there between -pi/2 and pi/2, then we have all those answers. So that, to me, whenever I first went over the inverse sine function, all I really cared about was how to get the answer, but I never really thought about why am I getting the answers that I'm getting. So that's the reason why. That's the reason that I've read about and that I've come up with and makes the most sense. This is two consecutive quadrants where sine is defined and in one of the quadrants sine is negative, the other quadrant sine is positive. With that said, let's see how we work out the inverse sine problems. If I want to take the inverse sine of 1, then I have to say to myself, the sine of what is a positive 1? And so I have to know those common angle measures. I have to know the values of those common angle measures. Remember, the sine of pi over 2 is positive 1. So if we have a quadrantal angle, you have to remember those values. Okay? So inverse sine of 1 is equal to pi over 2. Inverse sine of the square root of 2 over 2. I have to say to myself, the sine of what would give me a positive square root of 2 over 2? The sine of pi over 4 is a positive square root of 2 over 2. So the answer is pi over 4. And you might want to write a note to the side telling why these answers are what they are, so that when you look back at your notes that you can understand exactly what you were doing. So right here beside where I have the inverse sine of 1 is pi over 2, I'm going to say because the sine of pi over 2 is equal to a positive 1. And the inverse sine of square root of 2 over 2 is equal to pi over 4 because the sine of pi over 4 is equal to the square root of 2 over 2. Well, what if I want to find the inverse sine of, let's say, negative square root of 2 over 2? Well, then I have to say to myself, the sine of what is a negative square root of 2 over 2? And what makes this tricky is, before when we would work out, say, the sine of the sine of an angle measure and get negative square root of 2 over 2, then we would be looking for the answer in the third or the fourth quadrant. And we would want the answer to be between pi and 2 pi. So we'd want a positive angle measure from the third or fourth quadrant. That would give us a negative square root of 2 over 2. But now, there's two ways that we can do this. I'm going to show you a longer way to do it, and then I'm going to show you a shortcut way that works for sine, and I'll tell you why it works. Alright, the longer way to do this, and I say the longer way, but it may make more sense to some of you, is to use the reference angle chart. Now we're going to have to use the reference angle chart for some of our inverse functions, so you might want to get used to using this again. And what we'll do is we say, alright, we know we want our answer from the fourth quadrant because we're taking the inverse of a negative. So we want the answer here. The tricky part is, not only do we want the answer from the fourth quadrant, we want it to be between negative pi over 2 and 0. So we want a negative angle measure. So what we can do is figure out what was the sine that gave us a positive square root of 2 over 2, or the sine of what was a positive square root of 2 over 2, and that was pi over 4. So our reference angle for this problem that we're currently working would be pi over 4. Now, if we want that angle measure in the fourth quadrant, we use this reference angle chart, and we would say 2 pi minus pi over 4. That will give us the angle measure in the fourth quadrant. So get a common denominator of fourths. So we're saying 8/4 times pi minus 1/4 times pi. That's going to be 7/4 times pi. So the problem with this answer is it's in the fourth quadrant, but it's not between negative pi over 2 and 0. So what we want to do, if our angle measure is probably about right here, about right there, what we want to do is we want to go one complete revolution around or back so that we can figure out the angle measure that's between negative pi over 2 and 0. So what we have to do is subtract 2 pi from that answer. Okay? So 7 pi over 4 minus 2 pi, get a common denominator, just like we did earlier. So we'll have 7 pi over 4 minus 8 pi over 4, and you'll get negative pi over 4. So that means the inverse sine of negative square root of 2 over 2 is negative pi over 4. Now that, to me, makes sense if you are really good with the reference angle chart and you have no problem with subtracting 1 revolution. However, there's a little quicker way to do that. What you can do is, if you find the answer from the first quadrant, that's where the inverse sine of the positive square root of 2 over 2 is at pi over 4, then you can just make the angle measure negative when evaluating the inverse sine of negative square root of 2 over 2. And it'll always work like that for inverse sine. Some of you may be thinking, wow, that just seems like too big of a coincidence. But if you recall the even-odd property for sine, remember the sine of negative theta is equal to the negative sine of theta. So that's why we can just put a negative in front of our angle measure. Because if I was evaluating the sine of negative pi over 4, that's the same thing as the negative sine of pi over 4, which would be negative square root of 2 over 2, which is what we were taking the inverse sine of there. So because of the even-odd property, if you can figure out the reference angle, or the angle in the first quadrant, where we would find, say, the inverse sine of positive square root of 2 over 2, if you can figure that angle measure out, then you can figure out the inverse sine of negative square root of 2 over 2 by simply taking the answer that you got from the positive and making it negative. And that will always work out for inverse sine. Let's try another one of those. Let's say we had the inverse sine of negative square root of 3 over 2. So here's what I would want to think. I'd want to say, okay, the sine of what is positive square root of 3 over 2. And of course, then the first thing that pops into your head would be that the sine of 60 degrees, or the sine of pi over 3, is equal to a positive square root of 3 over 2. So all I have to do is make that angle measure negative, and that will give me the answer for the inverse sine of negative square root of 3 over 2. So it'd be negative pi over 3.